My name is German Karnup. Now I'm going to tell you my solution of problem number 4, electrostatic copier. The problem is, if you're up against each other two sheets of paper, one which contains text, they become electrified. The electrical pattern that's formed on the clear sheet may be endless slightly to restore the text depending on the various parameters. Propose and build a setup to recover an image of the original text with the highest possible resolution. The plan was as follows: to wrap the sheets, to act on a clean sheet of the developer and look at the result. As a developer, it was necessary to use material that reacts strongly even to a small field. We didn't find anything better than a regular toner for laser printers. Let's start by playing the effect. For the purity of the experiment, a setup was assembled that made it possible to evenly distribute the pressure between the sheets and their relative displacement during friction. When we wrapped two identical sheets with one which being an image, we didn't see any effect. We assumed that this was due to the drawing of the charge and took a closer sheet as a clean sheet. In this case, the effect was immediately noticeable, but if this effect is electrostatic, we blew out the toner. A week later, we carried out a grounded foil and look at the result again. It can be seen that the image is similar to what we received immediately after friction. It means that there is in general mechanical effect, but not electrostatic. In the end, we brought the wrapped paper to the toner particles under voltage from 60 volts to 10 kilovolts. As you can see, there is no result again. So we have finally convinced that there is no electrostatic effect, but only mechanical. However, if you take a stack of papers and write something on the first sheet, then, depending on various parameters, you can read the information on several sheets underneath the first sheet. And what do we have now? We conducted a series of experiments to observe the effect, made sure that the effect from the task isn't observed. However, we observed the effect by changing the procedure of applying text and friction of sheets. And we will work with this phenomenon. Let's give a qualitative explanation of the phenomenon. How is the charge formed? During the writing with the ballpoint pen on stack of papers, the sheet is beginning to shrink. Moreover, during crashing, the sheets rub against each other and a triboelectric effect occurs. The charge arising from friction is a function of the friction force itself. And since friction isn't uniform, see the figure, it's practically absent on the axis of the pen. Then friction depends not only on pressure, but also on the angle between the friction force and the base. From the mechanics of the contact interaction for the model of the ball and the elastic half space, we know the formulas of pressure and A radius, where A is the radius of the contact spot, P of R is the distribution of the pressure depending on the distance from the axis, P0 is the pressure on the axis, H is the height of stack of sheets of paper, and D is the depth of the crash. We know from articles on contact geometry that H is proportional to A. Then we obtain that the pressure is inversely proportional to the square of H. As a result, using previous results, we obtain that the surface charge is a function of H in power minus 2 or capital R in powers minus 1. We will check this equation later in our presentation. As already mentioned, the surface charge arising during friction deformation. The substrate paper system can be considered as a capacitor, one of the places of which has zero potential. And from the known electrostatic formulas, we obtain the potential created by the surface charge. So we explain the effect qualitatively using the theory of electrostatics and quantum mechanics. And as a result, we got relations that we're interested in, which we will check in the experimental part. Let's get to it. The image appears as follows. A sheet of paper with a perturbated area is placed on the ground with substrate. A Mahler film is on top, and a needle under a voltage of 8800 volts electrifies the whole system. During electrification, Mahler receives a uniform surface potential, but under the action of a strong field, the full-Frankel effect occurs. It means that charge flows through the electric. The remaining non-uniform charge creates a non-uniform surface potential at the perturbated area. As a result, there appears a non-uniform electric field, and this non-uniform electric field attacks the toner by wearing force, and we can see an image. To fix the writing speed, force of pressure, and its error, an additional setup was assembled. The writing force is controlled by Kinching cells and is regulated by 250 grams weights. Yeah. The speed is indicated in the microcontroller, which controls the motor, and the motor is already pulling the system. Now you can see a general equipment that we use in our work. We get electric field by high voltage power supply and used an ordinary office paper A4 format. Taking the weights as rest as the 0 point, we plotted the weight deviation and took the average deviation as an error. A photo of the resulting image was analyzed using a script for MATLAB. It calculated the average intensity of the column and plotted the dependence of the average intensity on the coordinate of the column. Then we entered the parameter as contrast, which is calculated by this formula, where N1 is the average outside intensity and 2 is the average intensity in the image area. To determine the experiment 8H, 8 experiments were carried out, and an average plot of the contrast versus layer number in logarithmic coordinates was constructed. So the experiment is determined by the slope coefficient. Linear approximation shows a slope of minus 2.16, and within an error, the experimental results are consistent with the theory. That's good. In addition, from this experiment, we determined the dependence of the maximum depth versus the writing force. Next, we investigated the influence of the radius of the writing instrument on the intensity. The slide illustrates a photo of the first node zero layer with some traces from different tips. Since the friction force isn't proportional, since the friction force is proportional to sinus of angle, it's obvious that the friction force when using a larger radius is less than that of from a smaller radius. You can see an average logarithmic plot of the contrast versus radius. The slope is minus 1 to 25, and we can see that our prediction is is correct. During our research, we discovered an interesting effect. If the print is deep enough, then the intensity in the center of the image is the same as in the unperturbated area, as you can see. It can be explained by the fact that the perturbation potential is proportional to the distance from the grounding to the surface. So, in some cases, the image will be better if you put the layer upside down. We suppose that there is a critical depth of crashing, upon reaching which it's necessary to change the orientation of the layer from the direct to reverse. The depth value was found from the intersection of the average intensity graph for the direct and the reverse orientation. From the graph, we obtained that the depth value is 40 plus minus 4 microns. By the end of the experimental part, I'd like to demonstrate to you a few more plots. The first one is the plot of contrast versus writing speed. The second one is the dependence of contrast versus storage time and layer number. And the results of our works as follows. We obtained a phenomenon that best suits the condition of the problem. Then we found out that paper is electrified due to the turboelectric effect. The setup was demonstrated to develop the text, and method of image analysis was used. The dependence of the contrast of the image of the thickness of the sheets and the radius of the writing instrument is theoretically found, which is confirmed experimentally. And we found an optimal paper punching depth. When the depth is reached, it's necessary to change the orientation of the sheets during development. And finally, we have determined that under normal conditions, you are able to read a copy of the original text 2 more pages below 0, and also brought the best and the worst conditions for the development of the text. And a little addition to my presentation is for the first one is theoretically estimate intensity of storage time. It's would be pretty useful for this work. Then use a filter for image analysis to minimize the oscillation of the contrast, and finally explore and different types of paper, not only Office A4 format, but another one. Thank you. Now I'm ready to answer your questions.
The presentation was very nice in the sense that it used animations and the graphics were pretty good. And the mechanism for the controlled rubbing was also the force back also good. However, there were some points that were still unclear due to the speaker talking too quickly. For example, the use of toner. How can one claim that the toner claims that the toner marks are marking electrostatic regions on rubbing, because that's a different case altogether. Secondly, the theory did not mention, the theory was based mainly on the fact that there is some deformation due to the in the process of text writing. However, if one looks at the example of printers and stuff, then they use toners, and which does not put any damages on the paper as such. So that part could have been included. So other than that, the model only used spherical pointers. If it had some different more shapes, it would have been still better. However, for first approximations, this is pretty good. The graphs were also the standard error bars and were also very nicely done. Um, However, if the graphs could have been elaborated a bit more, it would have been better. Okay. Apart from that, they only used one type of rubbing. If they had used different types of methods like pressing or um rubbing vertically or something, that could have given the problem a very nice edge. And um, um, and apart from that, and there were some points in the graph that were off by a significant amount. So the possible reason for that was also not discussed. Um, Other than that, the use of, I guess it was M something related to M mailer. So that was not clear that what it was. And lastly, I'd like to say that the that maybe if you could have tried with different type of text material like crayons or paint, something like that, and see if these can be used, then it would have been a better.
First, I'd like to answer your first question about toner and electrification. I told this in the start of my report. We used the toner because it was invented to electrify good, and how printers works. They electrify the toner, and electrify the toner then covered on the paper. And because of this, we used exactly toner, but not something else. Next question about about errors. Yeah, we. I didn't talk that we use a deviation as an error. We calculated error as, for example, by square mean method and absolute errors and etc. But the deviation isn't an error. Error was specially calculated. And your final question about deviation of my points on slide number 26. The answer is you also now you see the photo of the experimental data, and as you can see, there is a very randomized in outside area the contrast. There are a lot of toner and sorry. Oh, I'm sorry, I didn't start a demonstration. Can you see it? Hello. Okay.
Yes.
You see the toner, the non-uniform distribution, but because we have some random parameter in any experiment, we have a deviation from the fit.
Do you have did you try to find out why there were some deviations in your experiments? Like, can you sort of empirically explain these deviations? Like, were there some sort of factors which caused these deviations from this linear result in your plot in slide number 26?
Yeah, the first factor is not ideal accuracy of the method of writing. You can see a deviation over here. That is the part of our error. And the second one is the method of analysis image. You can see an isolation, and on the next slide, on the exit slide, I wrote that using of filters for image analysis will help in this way to minimize the error by the analysis.
Acha. Okay, and do you think that you answered the problem question, because the problem question specifically asked that you have to rub two pieces of paper and then you have to analyze it with the charge that is produced, but you use toner, but you skipped that part and you use toner for the charge. So do you think
Okay.
that your approach to the problem was maybe you interpreted it differently, but do you think that this is how you should have done it?
Okay. First, I don't know how is it possible to see an image without any deviation just on after rubbing two sheets. I don't know. You should to act on that sheet something to see the result. And the first your question is that because we write about campaign the stacks are shrink and wrapped, so the conditions is we did this, but the conditions wasn't exactly, and the phenomena from the task we didn't observe this, and we proved that this was the mechanical effect. Because if there were any electrostatic, then after 10 we can say that there is no electrostatic in the task. We condition of the task and look the effect.
Acha, so you did not take the approach that was mentioned in the question, which was an electrostatic approach, and you made it a mechanical approach. Is that correct?
Sorry?
The approach which was explained in the problem was of electrostatic nature, and you made this problem of a mechanical nature. Is that correct? Do you think that's a correct way to put it?
That's okay. What?
Do you think that's the correct way to put it? That the problem which was mentioned in the problem was to take an electrostatic approach, and you took a mechanical approach. Am I saying it right? Do you think that I could say it like this? I mean, you did get the text in the end, but your approach was different to the approach proposed in the problem, right?
We used with the mechanical and electrostatical phenomena. And that I think they thought about this. That
because in during the first slides you said that you sort of proved that it wasn't possible to shift the charge or to electrostatically analyze the paper, right?
Yeah, it's not possible when you wrap two sheets just like this. If you see me,
Do you think is there any qualitative explanation of as to why you think that it's not possible? Or did you maybe do some experiments?
Unfortunately, no, because we don't know the whole theory of triboelectrics, phenomena. It's very dark them in physics. So
yes. Okay, so what did you infer from that? That if you rub two sheets of paper together, they are not going to get charged?
If you wrap two sheets of paper, I think that there is not enough. Maybe Okay, we thought, and I told this, that when you wrap two sheets, because of the structure of the sheet, then charge just drawing from the sheets because this the structure of the paper is good conditions for going charge away.
Okay. Hmm. Okay, but the problem was to analyze the text, right? So do you think that the writing on paper could have some different effect? Like it could maybe induce some charge, because then you have, as you mentioned, the triboelectric effect, because then you don't have just two sheets of paper anymore. You have some sort of some ink or some other material in between as well. Do you think that could have become electrified? And do you think that and I also want to know that did you perform some experiments to sort of negate the presence of electrostatic charge in the beginning, or was that just your qualitative approach?
I'm afraid I don't got your question. Did you say about why we don't have charge on the ordinary paper, but when we write, why we have charge? Yeah, is it a question?
Yeah, sort of. You said that we don't usually have charge on normal paper, but do you think that if we introduce some sort of ink on it, do you think that could have caused the charging which was mentioned in the problem? And I also wanted to know as to why you negated the presence of electrostatic charge in the beginning. Did you perform some experiments and get some results on it, or did you just qualitatively eliminate this possibility just based on text on literature?
Okay, first your question. If you see on this picture, you will see a pit, and we know physics, and we know that in a pit the electric field is pretty bad, and the drawing of the charge from this pit is pretty bad as a result. But even with the paper structure, but we didn't prove
The reporting.
qualitatively because I repeat, we don't have a good. Okay.
Okay, so my question on this slide is, what relation do you assume between sigma and F?
Okay. Yeah, that's a really good question. Actually, without triboelectric theory, we don't know exactly what type of relation between these two quantitatives. But we suppose that and tried to yeah this type of relation, and as we see, this type is work in the area of our task. Maybe if the friction force will more, or I don't know, less, this equation won't work, but in our conditions we prove that that's useful.
And for my second question, later in your results, you showed us a graph where you tested this sigma versus R, and you found a slope of minus 1.25.
26, yeah, that's a little error. Yeah,
Yeah.
actually there is 1.6 in the result is 2.6. Yeah, that is an error. The actual value is 16. I'm sorry. Just it's not. It's old data, and yeah, from the interaction. Yeah.
Thank you for answering my questions. I would like to ask a question to the opponent as well. you spent some time pressing the reporter about the mechanical versus electrostatic approach to analyzing the text. Why do you believe that the solution should use an electrostatic approach?
We only felt we only wanted to see how they interpreted the problem. Did they interpret it to be open-ended, like you could take any approach, or did they first try the electrical approach and then they and then if they concluded that electrostatic charge transfer is not possible, then they took the mechanical approach. I really wanted to know whether what they claimed was had some basis behind it, some experimental basis behind it.
Yes, maybe I wasn't clear enough. I just want to know, why is the electrostatic approach important to you? Usually the reporter is free to choose their own method.
Maybe because it was mentioned in the because it was mentioned in the question, and also because they at the beginning of the slides they said that electrostatic charge transfer was not possible, and
I think we should let our jury member ask questions now.
okay.
Yeah, I'd be happy to ask questions if you can hear me.
Yeah, I can.
Yes. So I do have a question for both the reporter and the opponent. What if instead of using a pen, whether it's a ball pen or a pencil, whatever, what if you use the printer and print the letter A on a piece of paper, leaving no dip, no grooves? Would you think you could still reproduce it? And maybe the reporter can start answering.
As I mentioned correctly, that if we rub not two clear sheets, but sheet with something printed, we did this experiment. We first tried the circles printing. Then we developed this by our first algorithm. We developed it immediately after rubbing. Then we, after a week, we called a grounding foil, and then we developed it again, and we saw that there is an image was safe. Also, we tried with paint, and not only ordinary paper, but on a glossy sheet of paper, and we can see only scratched. Yeah, and we also tried to do the experiment with ourselves. Yeah.
Okay. And the opponent, do you have something to say about this?
I think that yes, we can reproduce it once we detect the charge, and if we theoretically think on it, we can see that on the printed page, the printed text is actually a different material. It's because of that the toner used in the printer. So and different materials, they come in different positions in the electrostatic series, and so if you rub two different materials against each other, charge is transferred. However, there is one thing, that the charge transfer may be small, because eventually you are rubbing paper over paper. But again, those small charges, they can be detected by constructing some or designing some electrostatic copier, whichever way you wish to design it. And once you detect those small charge transfers that have occurred, you can recognize different patterns and then obtain the original text on after the pattern analysis are just transferred.
Can I say? Even with a small charge, we should see this under the so gentle voltage because, yeah, but we didn't.